I say we just listen to music the whole time. How about that? All right. Anyone shows up now, just let them in later. We got a quiz tomorrow over 9.1 and 9.2. So what we're going to do today is we're going to review 9.2. We're just going to go over all of the different types of graphs that we had in 9.2, kind of review them. Hopefully I've made a process that makes it pretty straightforward for you. So if you got any questions, as usual, type them in chat or unmute yourself and just shout it out, and I'll stop and I'll try to answer any questions you might have. So let's share the screen here. Oh, that's underneath. There we go. I got it. All right, so let's get going. If you had a chance to print out the notes, you can play along. Otherwise, just kind of pay attention. Make sure you're doing your homework. Make sure you're practicing these because on the quiz, you're going to have to graph these, show the chart, and take a picture and turn it in like you've been doing on Google Classroom. So here we go. To start out with, we have circles. We just have 5 cosine. So nothing's added to this. The coefficient is 1. This is a circle. Now you can make a chart for this if you want. By the way, these graph from 0 to pi. Circles always graph from 0 to pi. But you're only really going to get 2 points. And the only 2 points you're really going to get are the pole and 1, 2, 3, 4, 5 out here. So you have to know that these are circles. Now, cosine affects the x. So these circles are either on the right x-axis, so to speak, if this is positive, and on the negative x-axis if we throw a negative in front of there. So these are the only 2 points you'd get if you use the process that I have, so you got to get the other 2. Now, the diameter of the circle is 5. It's not the radius. That's not the radius. That's the diameter. So the radius is 2.5. So if we go over to 2.5, that's actually the center of the circle. And if we go up 2.5, that puts us about right there. Down 2.5 puts us about right there. And then we can draw, you know, a decent circle. Circles are kind of hard to draw, believe it or not. Now, if this said -5 sine of theta, r equals, then that would be a circle down here. 1, 2, 3, 4, 5 down here. The diameter is 5, 1, 2.5. The radius is 2.5. So then we'd be over here. Oh, right. Something like that. That would be the -5 sine. Sine affects the y, so that would put the circle down at the bottom. Over here, I see I have 3 minus 5 cosine of theta. Now, 3 minus 5 is -2. So this one is going to be an inner circle. Inner loop. I shouldn't say circle. It's not a circle. Inner loop. There we go. And we're going to have to go from 0 to 2 pi on this. And we're going to double that coefficient, which is 1. So we double that. We're going to count by pi over 2's. And yeah, that should be it. That should be enough. So we have theta and r. So we're going to go 0, 1/2, 2/2, 3/2, and 4/2. When we plug 0 in, cosine of 0 is 1. So we get that inner loop right away. We get that negative value. Pi over 2 is cosine of pi over 2 is 0. So we get 3. Pi, cosine of pi is -1. So that we get 3 plus 5 because we're going to take that -5 times -1. It's going to be 8. 3 pi over 2 is 0. So we get 3 again, and then 2 pi is back to the beginning. Cosine of 2 pi is 1, so 3 minus 5 is negative 2. So at 0 radians, going this way, we're back negative 2, so we're back the other way. That's over here. Pi over 2 is 3. 1, 2, 3. Pi is 8. So at pi radians, we're over here at 8. 3 pi over 2 is 1, 2, 3. And 2 pi is back to the beginning. It's at negative 2. Now, granted, we only have 4 points, but you need to practice this a little bit so you have an idea of what these look like. So if we plotted a whole bunch, thousands and thousands of points, this is what it would look like. So we're going to go a little wider than this point. This is not the widest point. Now, somewhere we would hit the pole. Now, we don't need to find that value. We just need to know that it happens somewhere. It's going to cross the pole. It's going to loop around, cross the pole again. So there are 2 points on this graph where R would be 0. Now, we don't need to find those because we just know it happens somewhere. And then we're going to go wider than this point, and then we're going to loop around and go back to the beginning. That's not too bad. It should be pretty round, pretty wide. That's probably not quite wide enough, but I'd call that pretty good. So an inner loop, how do you know you have an inner loop? It's because the process that we've picked, by doubling the coefficient and going to 0 to 2 pi, we get a negative R. That tells me that's going to be an inner loop given the process that we're using to graph these. Now, 5 minus 3, by the process that we're using, we cannot, well, just in general, we cannot get a negative R, and it would be impossible to get even 0 as an R. So this one is dimpled. A dimpled limousin. Now we know it's dimpled because 5 is not double 3 or bigger than double 3. So it's not 6 or more. If it's double that, like over here to the right, this is going to be convex. So this one's convex because 7 is more than double 3. So now it's all the same, which is good. I mean, if we can establish a rules that work every single time, that's always good. We don't have to alter the rules just because we have a different graph. This graphs from 0 to 2 pi, and we're going to count by pi over 2s. So 0, 1 half, 2 halves, 3 halves, and, oh, wait, yeah, and 4 halves. I'm going from 0 to 2 pi. So if I plug 0 in for cosine of 0 is 0, and so we get 5. Pi over 2 is 0. Cosine of pi over 2 is 0, I mean. So, no, wait. You know, you're probably yelling at me. Cosine of 0 is 1, so 5 minus 3 is 2. Cosine of pi over 2 is 0, so that's 5. Cosine of pi is negative 1, that's 8. Cosine of 3 pi over 2 is 0, so that's 5. And then cosine of 2 pi is 1, so we're back to 2. There we go. So 0 is 2. Pi over 2 is 1, 2, 3, 4, 5. Pi is 8. 3 pi over 2 is 1, 2, 3, 4, 5. And there we have the 4 points. Now this is going to be dimpled. Again, I want to repeat it so that maybe it'll sink in. It's dimpled because 5 is not doubled 3 or more. But it's also bigger than 3. You got to consider that because there will be no negative R's. There will be no R's that are 0. They'll all be positive. All right, so this is starting off not too good, but it dimpled right there. And then loop around nice and fat, nice and round. That's probably too sharp there, but that's all right. I'm not gonna hold you to a perfect graph. Just do the best you can, and if it's relatively good, we'll give you points for it. So I'm not too worried about these being perfect, but do the best you can. We're not all artists, especially me. All right, now this one is convex because 7 is more than double 3. Double 3 or more are gonna have convex. So theta R, this graphs from 0 to 2 pi. And we're going to count by pi over 2s, just like always. So 0, pi over 2, 1 half, 2 halves, 3 halves, and 4 halves. Kind of looks like a 1. It's a 7. That's a 7. All right, so cosine of 0 is 1. 7 minus 3 is 4. Pi over 2 is 0, so that's 7. Pi is -1, so that's going to be 7 plus 3. It's going to be 10. I don't have 10 spaces, so we're going to have to go by 2s. So I'm going to mark that with a 2. Now it's hard to read, but that says 2. So each space is worth 2 rather than 1. 3 pi over 2 is 0, so that's 7. And then pi is negative, let's see, pi. Oh, how come I pi twice? 2 pi. Cosine of 2 pi is 1, so we got 4. So 1, 2, 3. No, I'm going by 2s. 2, 4, right there. Going by 2s. Pi over 2 is 7. 2, 4, 6, 7. Up there. 10. 2, 4, 6, 8, 10. Over there. 3 pi over 2 is 7. 2, 4, 6, 7. And then we're back to 4. Now this one, it looks kind of like a circle because it's convex. It bubbles out there rather than being dimpled and loops around. So those are very close to being a circle. It's just kind of dented in on the right side. There's no real center for these. Oh, that chord sounds bad, doesn't it? All right. All right, so what do we got? We got circles. Cosine is either to the right or to the left, depending on whether it's positive, negative. Sine would be up or down, a circle up or down, whether, depending on whether it's positive or negative. And that 5 right there, the coefficient of sine or cosine, that's the diameter. It's not the radius. If we have a negative, that causes an inner loop. By the process that we have, the only time we're going to have a negative is if we have that inner loop. If this is less than double the coefficient of cosine or sine, then this is going to be dimpled, less than doubled. If it's double or more, if that number is double more than that one's going to cause the graph to be convex. Now, if dimpled or convex are on the test or the quiz, make sure you give me a well-defined dimple or maybe a well-defined convex. Be very careful at this point on the test or the quiz, because I'm going to look at it and I'm going to try to decide whether you drew it as dimpled or convex. Make sure it's clear. Exaggerate it just a little bit so that I can definitely know. Don't make it vague for me. Makes it hard to grade too if you're vague. All right, we just got 2 left, kind of quick notes today. This one, 3 minus 3, that's going to give us 0. Now, we would get 0 even if it was r equals 3 plus 3 cosine of theta. The fact that it's minus doesn't really matter. The minus tells us where it's going to bubble out to, but it doesn't say that this is the only case where you're going to get 0, because when cosine is -1 here, then we're going to get 0 for this one also. Now, with our process, if we get 0 in our chart, this is a cardioid. Cardioid. Now, I don't want you to think that that's the only time you could possibly get 0 for R, because back at the inner loops right here, you would get 0 twice. So when I say when we get 0, that means by the process that we've developed, by doubling the coefficient, if we get 0 on our chart, that means we're going to get a cardioid. But I don't want to send the message that this is the only time you could possibly get a 0 for R. That's not what I'm trying to say. All right, so these are 0 to 2 pi also. Most are 0 to 2 pi, except for circles and the one I have over here, which would be odd roses. I call them odd because theta would have the odd value. All right, so these are 0 to 2 pi. Again, we're going to count by pi over 2s. We're going to double that coefficient, pi over 2. Theta, how am I doing on time? I can't even, yeah, I think I'm way ahead of it anyway. R, 0, 1/2, 2/2, 3/2, and 4/2. This is a cardioid. All right, 0. Cosine of 0 is 1, so we have 0 right away. Pi over 2 is 0, so that's 3. Pi is -1, that makes this 6. 3 pi over 2 is 0, so we have 3. And then 2 pi is 1, we're back to 0. So we get the pole right away at 0. Pi over 2 is 1, 2, 3. Pi is 1, 2, 3, 4, 5, 6. 3 pi over 2, 1, 2, 3. And then 2 pi is 0. So we're going to loop around like this. is a cardioid. Cardioid and dimpled. Cardioids dimple when they hit the pole. So we'll make sure we exaggerate that a little bit, and then it loops around. So hopefully, you know, you have this nice exaggerated dimple there when you graph these. So I can see that you knew it's a cardioid, you knew it needed to be dimpled. All right, the last one. This is a rose. We have an odd coefficient. When we have an odd coefficient, we're going to graph from 0 to pi. That'll complete the entire graph. On this one, we're going to count by pi over 6s, and we should have 3 petals. 3 petals. So when it's odd, it's the same amount of petals. When it's even, you double the value, and that's how many petals you would have. You double that coefficient. So the coefficient of theta really tells me a lot about what this graph looks like. So we have theta and r, 0, 1/6, 2/6, 3/6, 4/6. This is the one that doesn't reduce, 5 pi over 6, and then 6/6. Now this is the one where we have a pattern, and I like using the pattern because then I don't have to plug all of these values in. So let's start with 0. Cosine of 0 is 1. 1 times 8 is 8. Then pi over 6. Well, if I plug pi over 6 in here, 3 pi over 6 becomes pi over 2. So cosine of pi over 2 is 0. So we get 0 here. Now it goes -8, 0, 8, 0, -8. So every other one is 0. And then every other one goes positive, negative, positive, negative. And you can plug those values in if you'd like, but that's the pattern that happens every time because we're doubling this coefficient. We get this pattern here. So 0 is 8. 1, 2, I'm way out here. Now with cosine, that first petal is always on the x-axis. For sine, that petal is always going to be in the first quadrant somewhere. So we've started 0. Pi over 6 is 0. So now if we plotted a bunch of points in between those two angles, we'd have this curve right here. Pi over 3 is -8. So pi over 3 is back here at 4 pi over 3, really. All right, and then loop around if we plotted a bunch of points. Pi over 2 is 0. So once we get up to pi over 2, like this, kind of in line with pi over, 3 pi over 2, 0. 2 pi over 3 is 8. That's up here. So it'd look like something like that. 5 pi over 6, which is this angle right here, is 0. So we're back to 0. And that should be nice and rounded, not real sharp. I end up drawing these a little too sharp. And then pi, pi over here is back to -8. So then we get right back to where we started. We notice that to complete all 3 petals, we only have to go from 0 to pi. So if you go from 0 to 2 pi, you just end up graphing it twice. That'd be a big mistake in calculus, but here, I mean, you wouldn't really, I think once you're back to the beginning, you wouldn't just keep going on and graphing it. So that 0 to pi, 0 to 2 pi stuff is really important next year for Calc BC. All right, 34. So this is we're going to end a little early today. There's just not a lot to do, not a lot to talk about other than the graphs that we've seen. We have a worksheet for today, and I believe I've put that in Google Classroom already. It's also on my website, so there's a couple places where you can go to get the worksheet. There's 2 of them because both of them don't really have a whole lot of problems, and altogether it's just kind of like a normal assignment. So I'm going to end with, just stay positive, stay motivated. You guys are honor students. You're the best in your class, and I see that every day. Just keep on keeping on. I know there's a lot of distractions in your house. I know there's a lot of other things you would enjoy doing, but just take the time to get your homework done, get your classwork done in all your classes, and try to stay positive through all this. Are there any questions? Tomorrow's another 9192 quiz, and 91 will be on it. Just a few questions from there. So make sure you're reviewing the fact that given 1 point, you can write 4 different ordered pairs for 1 point with polar. And essentially it's 2 with the positive radius, 2 with the negative radius. And each of those has a positive, negative angle, positive, negative angle. So in combination, you can have 4 points for every single point. I did see that on the quiz. There's, I believe, 2 questions where you're going to have to graph them on paper and maybe take a picture and turn them in. If you don't have a capability of printing out graph paper, polar graph paper, just handwrite the circles, as many as you need, and we'll call that good. Do the best you can on that. Otherwise, that's all I got for you. Any questions for the good of the cause? All right, I keep posting videos for the class without the Zoom. I keep posting the Zoom, so you can go back and review those if you have a chance. Otherwise, have a great day. Have a great weekend. Good luck on your quiz tomorrow, and then the following week, we're going to wrap the chapter up. Take care, you guys. We'll see you next time.